Section 5.2, Example 6 on page 351, we have a complex fraction is a fraction that contains one or more fractions in its numerator, in its denominator, or in both. You can simplify a complex fraction by dividing its numerator by its denominator. Any complex fraction of the form a over b divided by c over d, where b does not equal 0, c does not equal 0, and d does not equal 0, can be expressed as a over b divided by c over d. For example 6, it says, what is the simplified form of 1 over x minus 2 divided by x plus 3 over x squared minus 4? We can rewrite this exactly how it sounds. So 1 minus 2 divided by x plus 3 over x squared minus 4. Now let's get rid of the division symbol, turn that into a multiply by, and flip our second expression. Now we can check what needs to be factored. 1 is a constant, so we don't need to factor that. X squared minus 4 is a difference of squares, so we will factor that. X minus 2 has nothing in common, and x plus 3 has nothing in common, so we will just factor this numerator on the second expression. X squared minus 4 is a difference of squares. Remember, a difference of squares is a squared minus b squared equals a plus b times a minus b. X squared is already written as a perfect square, however 4 is not, but we can rewrite it as 2 squared. So now our a is x, our b is 2, and we have x plus 2 times x minus 2. Now we can rewrite x squared minus 4 as x plus 2 times x minus 2, and we can check the numerator and denominator to see if we have any common factors. So in the numerator we have 1 times x plus 2 times x minus 2, in the denominator we have x minus 2 times x plus 3. Notice there's an x minus 2 in the numerator and the denominator, so we can eliminate those. And we're left with 1 times x plus 2, which is just x plus 2 over x plus 3. And that is the final answer. All the work is written out on the next couple of slides. And now I would like you to simplify g plus 2 over 3g minus 1 divided by g squared plus 2g over 6g plus 2.